Alright, so this is section 6.1, day 2. I'm going to record the lesson, so hopefully you don't mind. I've only got three boxes for you today. We're going to start with a warm-up. So on the left-hand side, I'd like you to try those two problems. Alright, Taylor, what'd you get for the first one?
X equals y over 5 minus 2.
X, let me write that down in a different color so I can see it. X equals y over 5 minus 2?
I mean, yeah.
I think it's the other way around. Isn't it 5 over y minus 2?
Yeah.
Okay, you should have got x equals 5 over y minus 2. Is that what you guys got? Uh-oh.
Nope.
Why isn't it 1 over 5?
Yeah.
How'd you get that?
Is it y over 5?
I thought so, because you're dividing, because 5 is on the top to you.
Is that what we all got? Okay.
But you can't subtract 2 from 1 over x minus 2.
So are we not convinced that this is right? We're not convinced that's right. No one else in the room got this? You got 5 over y. 5 over y minus 2. So is that the right answer? Uh-oh. Okay, here you go, guys. Y equals 5 over x minus 2. Here's what you should have done. Y times x minus 2 equals 5. Let's divide by y. Divide by y. X minus 2 equals 5 over y. X equals 5 over y minus 2. So yes, that is right. 5 over y minus 2. Okay? Alright, number 2. Alejandro, did you get number 2? F of 5 equals 1/4. Yes, you are correct. Alright, so we're going to be doing this, solving for certain variables in this lesson today, so that's why I wanted to warm you up with that. Okay, so what we're going to do, our first idea is we're going to verify that functions g and f are inverses of each other. So we're going to say, let's let f of x be the function 3 minus 2x, and let g of x be the function negative 1/2 times x minus 3. So what you need to do to show that f of x and g are inverses of each other is you need to show that f of g of x is equal to x, and you have to show that g of f of x is equal to x. What is that called? What is that called when we put one function inside of another function? Function composition. Exactly. So I'd like to set the first one up for you, and then I want you guys to set the one on the right. So I'll set this one up. So I want f of g of x. So I literally want f of negative 1/2 times x minus 3, because that's what g of x is. You guys agree with that part? Okay, now what do I do with that negative 1/2 times x minus 3? I substitute it in for what? The x on the what? On the f, yes. So this is going to be 3 minus 2 times the quantity negative 1/2 times x minus 3.
So this is to show that f of g of x equals x.
Yep.
Does that mean that that's the inverse?
Yeah, well, to show that these two functions are inverses of each other, you should show that when you plug one inside the other, you get the identity function y equals x out. Okay? So could you go ahead and please set up the g of f of x composition function on the right-hand side? Okay, is that what you guys got when you look at mine? Is that what you guys got? Same thing? No? No, outside. Is that okay? Alright. Alright, so I'm going to solve the one on the left, and then you guys are going to solve the one on the right. So here's what we get. So I'm going to work from the inside out. This is going to be 3 minus 2 times the parentheses, negative 1/2 x, and then plus 3/2. Is everyone okay with that first step there? All I did was I distributed my negative 1/2. Sound good? Alright, now I'm going to distribute my negative 2. This is going to give me 3. Negative 2 times negative 1/2 is a positive, well, 1, so positive x. And then negative 2 times a positive 3/2 is a negative 3. So therefore, the 3 minus 3 goes away, and I end up with x. Good. So on the other side, I should end up with the same thing. So go ahead and see if you can get. All right, here we go. So you should end up with this, right? Working from the inside out, this is just negative 1/2 times, well, 3 minus 3 is nothing, so negative 2x. Negative 1. What's 3 minus 3?
Well, you could do it that way too, but it still comes out as.
It's a minus sign, not a multiplication sign.
Yeah, this is a minus sign, not a multi. Wow. All right, well, this is very interesting. So,
It just mind blew him so hard.
They had to go home. They just had a headache.
all right. Well, here's what happens, okay? This 3 and this 3 add to 0, leaving you with negative 1/2 times the negative 2x, which gives you x. Well, so therefore, those two are the same.
It's selective distribution.
It's not. I feel so bad for you guys. I do, because I feel like you've been cheated somewhere along the way or something, you know? Yeah.
Selective distribution in algebra class.
All right. Well, we'll have to spend a different day on that.
There's one full day Daggett.
Okay.
Speaking class.
What you guys?
At f of g of x and g of f of x are indeed equal to x themselves. All right. That was a journey that we just had. Very interesting. Great adventure there. All right. Do you guys need that one? Some more? Okay. That was crazy. See if we can get through some more of these without any distributive property bone misconceptions there. Okay, number 2, let's see here. Let's do this one. The given function is 1-to-1, find its inverse. So I'm going to tell you that the function that we're going to deal with, f of x, is going to be 5 divided by x minus 2. And over here on the right-hand side, I'm going to write down the steps that we do down so you have them. So in order to find the inverse of a function algebraically, the step number 1 is we replace f of x with y. So I'm going to have y is equal to 5 divided by x minus 2. Alright, step number 2 is we're going to switch x and y. So just switch the x and y in their spots. So now x is equal to 5 divided by y minus 2. Step 1 is replace f of x with y. Okay, step number 3 is going to be solve for y. So this is the one that we did in the warm-up problem, remember?
Yep.
So I'm going to have x times y minus 2 is equal to 5. I'm going to divide by x on both sides to get y minus 2 is equal to 5 over x. And then last I'm going to add 2. So y is going to be 5 over x and then plus 2. And then step number 4, when you're all said and done, is replace y with f inverse of x. And that's your algebraic function. So f inverse of x is equal to 5 over x plus 2. And that's how you algebraically find the inverse for functions. So a guiding question I wrote for you on the left-hand side was, what are the 4 steps for algebraically finding f inverse of x? You might want to write that down so you know what to study from. What are the 4 steps for algebraically finding f inverse of x? Good question to answer. Yeah, I will.
There's only 3 though. Oh, JK.
I got 4 there.
I got you.
Alright, so I want to show you something with this. If I plug in, what is f of 3 to my original function? If I asked you what is f of 3, what would you tell me? No. All right. Sorry. Yeah, 5. I did something. I was thinking of something else.
Did I distribute wrong? Or?
No. Yeah. No, you got it right because 3 minus 2 is 1. So the input to my original function was 3, and the output was 5. You guys agree with that?
Yeah.
Now check this out. If I go down here, if I put an input of 5, what would my output be? 3. Isn't that crazy? They just switch. Isn't that sweet? So I switch basically the inverse function undoes every single function, every single input for an output, and it just replaces them. All right, so last one is a you try. So I would like you to try and find. Okay, Daniel, what'd you get for the F inverse?
F inverse of x is equal to 2 over x minus 3.
Do we agree? Okay, ladies and gentlemen, I would like to show you one more thing here, okay? Want me to go through that one? Yeah, sure. Here you go. Ready? So first you have f of x is equal to 2 over 3 plus x, right? Then you have y is equal to 2 over 3 plus x, yeah? Then you have x is equal to 2 over 3 plus y. Then you have x times 3 plus y is equal to 2. Why? Because I'm multiplying both sides by that. Divide by x. So 3 plus y is 2 over x. So finally, y is equal to 2 over x, take away 3. That's a terrible 3. Take away 3, and then you replace f inverse of x, 2 over x minus 3. Is that cool? Yes. Okay, now, check this out. Go back up to my original thing here. What is the domain of f of x? All round numbers x such that x is not equal to what? -3. Good. Okay, good. Check this out. What is the range of f of x? So think about this. It's a rational function, correct? It's a proper rational function because the degree on the top is smaller than the degree on the bottom. So where's the horizontal asymptote? Yeah, y equals 0. So the range of f of x is all real y such that y is not equal to 0. Okay, now. Yes, good. The range horizontally, right? There's a horizontal asymptote. So for the same reason, the vertical asymptote can't be part of the domain. The horizontal asymptote can't be part of the range. Okay? Now, take a look at the domain of f inverse of x. What do you notice? All real numbers x such that x is not what? 0. Not equal to? 0. Oh, there you go. And what's the range of f inverse of x? Not equal to, is it 3 or -3? It's -3. Because this one up there. So, the big idea here, I had this last guiding question, is how are the domains and ranges of f inverse of x and f of x related? Turns out the domain of f of x is equal to the range of f inverse of x, and the range of f of x is equal to the domain of f inverse of x. So they just flip-flop. Interesting stuff. All right, that was a good lesson.